Did an asteroid strike the Yucatan Peninsula 66 million years ago? Did it wipe out the dinosaurs? This is primarily a discussion about what caused the Chicxulub crater on the Yucatan Peninsula of Mexico. First, though, we'll put the dinosaur extinction enigma to rest. Let's begin with the KT boundary. The KT boundary, or Cretaceous-Tertiary boundary, or CP boundary for Cretaceous-Paleogene boundary, are the same things. It is a layer of sediment, part of the Earth, 1 to 5 millimeters thick, probably caused by the Chicxulub explosion of 66 million years ago. Allegedly, this layer encircles the globe. The thickest layer is nearest to the crater. This crater is noted for having a high concentration of iridium, a dense metal found in great concentrations in meteorites and earth-borne volcanic lava. This iridium-enriched band separates the Cretaceous period from the Tertiary period. Just take a look at the conflicting statements made by professionals. Everyone's heard of this scientific theory that states, before the Chicxulub impact, dinosaurs, crocodiles, turtles, tuatara, and even amphibians were thriving. The big impact wiped out all the dinosaurs because the dust-induced winter conditions starved and froze the dinosaurs within a year or two. The crocodiles, turtles, tuatara, and amphibians continued to thrive, including the former raptor dinosaurs that had already transitioned into the aves, the birds. The proof of this cataclysm is that no dinosaur fossils have been found above the KT boundary. Well, this will shock everyone. No dinosaur fossil has been found at least 1 meter below the KT boundary. It seems that the dinosaurs were dead even before the Chicxulub strike. What killed them was continental drift, which changed their environment. The Chicxulub event did nothing to the dinosaurs. The dinosaurs were extinct long before the Chicxulub explosion. It's worth taking note of scientific theories. Not all the evidence is included, which means that desired conclusions can be reached. The dinosaurs' demise is one example. My other video, Global Warming Juggernaut, clearly points to natural climate trends. Another conclusion is being pushed. Control and manipulation of food and fuel may be the goal. Anyway, now to the crater. For the sake of refreshing a few memories, about 66 million years ago, a tremendous explosion formed a crater estimated to be 100 by 300 kilometers in diameter on the Yucatan Peninsula. The world now knows this wonder as the Chicxulub impact crater. The question this analysis tries to answer is, what was the actual cause of the explosion? Impact explosions and volcanic explosions do not differ much, which is why the debate has been so heated and protracted. Both types of explosions yield almost the same byproducts, which are studied by Earth scientists. The results are interpreted a little bit objectively and a little bit subjectively. Take, for example, the three most talked about residual clues of Chicxulub: iridium, tektites, and shock quartz. Iridium is a metal so dense that most of the Earth's supply sank into the core and the mantle during the planet's formation. Volcanoes spew a goodly amount of mantle iridium during eruptions. The metal then solidifies in layers on the landscape and in dormant magma chambers. Meteorites and space rocks, coincidentally, contain significant amounts of iridium. These impact explosions embed some of the metal inside their craters and throw the remainder into the sky to eventually fall and rest on the ground. This is the first point of contention. Because meteorites hit suddenly, dust and debris are thrown up into the atmosphere at once. The heavy airborne iridium, therefore, usually descends evenly and disperses uniformly on the ground. A bubbling, sputtering volcano will leave an irregular, varied layer. the iridium pattern that was laid 66 million years ago is uneven, and volcanologists are quick to point this out. Many do not even think that most of the iridium came from Chicxulub, pointing their accusing fingers at the Deccan traps in India. Impact advocates make a good argument that it took years for the iridium to settle, so naturally, because of turbulent wind currents, it would have accumulated irregularly. Adding fuel to the debate, volcano advocates claim that there was not enough ejecta thrown from Chicxulub to account for the relatively thick layer of iridium, while impact advocates claim the exact opposite. A glance at the World Atlas may bring focus to this debate. Chicxulub and India are practically on opposite sides of each other in the northern hemisphere. A 100 million megaton explosion on the Yucatan may well have triggered volcanic eruptions in India, no matter what the cause. Tektites are small natural glass globules, once thought to be formed exclusively by the high-energy explosions of meteorite impacts. The Chicxulub scatter field is loaded with tektites. Volcanoes produce their own natural glass when the silica of lava flows solidifies quickly. This glass, called obsidian, is the approximate chemical composition of tektite glass, but the molecules are arranged differently. There has been not much debate about the different origins of each until recently. Over the past few decades, the magma chambers of several extinct supervolcanoes have been discovered. Boreholes have been drilled into some of these chambers to see what's inside, and interestingly, the core samples have yielded volcanically formed tektites. It's not hard to imagine tektite formation from a super explosive volcano as opposed to a saw in the ground that chronically oozes. So the next question is, were the Chicxulub tektites formed by an asteroid impact or by an equally powerful supervolcano? Shock quartz is another formation strongly indicating meteorite impact because specimens are created by great explosive forces. Quartz normally looks like chunks of glass or ice. It is sometimes transparent, but is usually filled with cloudy inclusions and planar fractures. Quartz may be either igneous or metamorphic. Shock quartz shows strong layering lines throughout the stone caused by either violent percussion or high-pressure squeezing. Superficially, shock quartz resembles sedimentary rock. Shock quartz is most famously caused by meteorite impacts, but there are two alternative production methods. The first alternative is the grinding of quartz between tectonic plate boundaries. The second, you guessed it, is by volcanic eruptions. This is not the end of the story by far because impact shock quartz looks uniquely different than the others. Once again, however, attention should be drawn to supervolcano magma chambers. The dust hasn't settled on this one, and the debate over shock quartz is currently as hot as a mantle plume. This brings us to the Chicxulub crater. Any crater may be formed by either an impact or an explosion. It is almost impossible to know the differences, especially after 66 million years. Some people nevertheless claim that the crater could have only been formed by an angled impact that sheared off the northern rim. My answer to that is to look at the lopsided Mount St. Helens crater. Now, let's get to the heart of the matter. What is under the Chicxulub crater that will uncloak the answer to the biggest geological mystery of this and the last century? For that revelation, the rock melt in the crater and the breccia beneath need to be identified. Breccia is naturally manufactured concrete, as opposed to man-made, and concrete is larger rocks and minerals embedded in finer grained mortar. Meteorite impacts melt rocks, which later solidify, but so do volcanic eruptions. Impact breccias, more specifically, contain iridium, tektites, and shock quartz in the mortar, without the inclusions of volcanically produced pyroclastic materials. Pyroclastic materials are ash, pumice, small lapilli rock, and larger tephra rock. Volcanic breccias may or may not contain the big three, but they must contain volcanic pyroclastic rocks. The Chicxulub crater contains all these pyroclastic materials. Expedition 364 of the International Ocean Discovery Program, a marine research collaboration, drilled into the Chicxulub crater in 2016 to find conclusive evidence of an extraterrestrial asteroid invasion. The evidence was to be the above-mentioned Big Three. The goal was to bore 1,500 meters into the impact crater because that's where the answers were determined to rest. Unfortunately, the drilling only reached a depth of 1,335 meters. Still, the expedition leaders claimed that they achieved most of their goals. Later, the mandate of the expedition seemed to change to 1,200 meters deep, which they achieved. Team 364 appeared to be college faculty and students. I'm sure they just plotted the areas to be drilled and didn't handle the machinery. Still, were these pocket protector Poindexters taken seriously by the oil riggers? Furthermore, I don't like the idea that Expedition 364 had a bias, expecting to find evidence of an asteroid or meteorite impact. Just look at their logo. I didn't bother reading their final report because I didn't trust it. In any case, I learned that other oil companies drilled at least 1,500 meters into the crater. Pemex, a Mexican petroleum company and no friend of the environment, has been drilling wells into the crater since 1952. A lot of oil comes from volcanic sources. It is no revelation that the rock melt sheet is andesite. Andesitic melt is volcanic igneous rock. Furthermore, this type of volcanic rock occurs near tectonic plate boundaries. It is striking that the Yucatan Peninsula lies above the convergent boundaries of three tectonic plates, the Cocos, Caribbean, and North American plates. It was probably exactly at that spot 66 million years ago. Boring into the crater has revealed a dioritic magma chamber underneath the andesite. Diorite is a type of volcanic granite manufactured above the subduction zones of tectonic plates. This opens the possibility that 66 million years ago, a large meteorite struck a supervolcano along the plate boundaries, or perhaps the impact at that volatile location created a supervolcano. It would explain the mixed evidence. It's worthy to note that the academic world and news media say it's an asteroid impact, but petroleum companies treat Chicxulub like an oil-producing dormant volcano. But as yet, no one knows for sure what caused the Chicxulub crater. Chicxulub may turn out to be purely a supervolcano. Volcanic activity was at its peak during the Hadean Eon and has gradually decreased through the Archean, Proterozoic, and Phanerozoic eons. The greater geologic energy of the past must have surely included higher intensity explosive eruptions. It has recently been discovered that the Great Yellowstone supervolcano contains a lower second magma chamber that is 4.5 times as large as the upper chamber. The smaller upper magma chamber already qualifies as super in size. If both chambers erupt, Yellowstone could generate an explosion to rival Chicxulub's. Maybe it needs to be triggered by an impact. I can't help but wonder whether the multiple catastrophic meteorite impacts from the Paleocene back through to the Carboniferous periods were, in fact, misidentified supervolcanoes. Meteorite strikes may have served as detonators, but I suspect that the supervolcanoes of the deep past were capable of producing their own cataclysms. Volcanology is in its infancy, and eventually the answers will come. And speaking of sciences in their infancy, climatology is also in its infancy. Please watch Global Warming Juggernaut, The Definitive Answer. Thank you. See you next time.